The Indian Monsoon. Before we analyze branches, winds, and rainfall maps, understand what we are studying. This is not just seasonal rain. It is a pressure-driven atmospheric system that controls India's agriculture, economy, water security, and even inflation cycles. To understand the monsoon, we must begin with the meaning of the term itself. What is a monsoon? A monsoon is a seasonal reversal of winds. In summer, winds blow from sea to land, bringing rain. In winter, winds reverse, blowing from land to sea, bringing dryness. Think of it as a giant heat engine. It collects heat over land, pulls moisture from oceans, and releases that moisture over the subcontinent. The direction reversal is the definition. Rainfall is the outcome. Now the question becomes, what drives this reversal? To understand the reversal, we must examine thermal contrast. Land heats faster than water. In summer, the Indian landmass becomes intensely hot, creating low pressure. The surrounding oceans remain relatively cooler, maintaining higher pressure. Air always moves from high pressure to low pressure. Now add the Tibetan Plateau. At high altitude, it acts as a powerful heat source, intensifying low pressure over northern India. You can imagine Tibet as a massive chimney drawing air upward, strengthening the inflow. But local heating alone is not enough. We must now look at the global system. The ITCZ, the Intertropical Convergence Zone. This is the equatorial belt where trade winds meet and air rises. In summer, the ITCZ shifts northwards, closer to the Tropic of Cancer. That northward shift pulls the zone of rising air towards India. Now comes the twist. The southeast trade winds cross the equator. Due to the Coriolis force, the deflection caused by Earth's rotation, they turn right and become southwest monsoon winds. And what pushes them? The Mascarene High, a strong high-pressure system in the southern Indian Ocean. So remember this sequence. Magnet, ITCZ shift, twist, Coriolis effect, push, Mascarene High. Now that the mechanism is clear, let's see how the monsoon actually arrives. Before the main arrival, there are pre-monsoon showers in April and May. In Karnataka and Kerala, these are called mango showers. They are important for crops, but they are not the monsoon. The real event is the burst around June 1st, the sudden onset of strong southwest winds. And remember, the monsoon is pulsating, not continuous. It has active spells and break spells. Duration, roughly 100 to 120 days. Now once it enters India, it does not move as a single wall of rain. It splits. The monsoon bifurcates into two branches. Arabian Sea branch, Bay of Bengal branch. The Bay branch is stronger because it travels over a larger water body and carries more moisture. Understanding this split is essential because rainfall distribution depends on branch pathways. Let's trace the Arabian Sea branch first. The Arabian Sea branch follows three tracks. First, along the Western Ghats, producing heavy orographic rainfall. Orographic rainfall occurs when moist air is forced to rise over mountains, cools, condenses, and rains. Second, the central track toward Nagpur. Third, towards Saurashtra and Rajasthan, where rainfall becomes scanty. Look at Mumbai and Pune. Mumbai lies on the windward side, heavy rainfall. Pune lies on the leeward side, in rain shadow. Rain shadow means dry conditions on the sheltered side of a mountain barrier. Now let's track the Bay of Bengal branch. The Bay branch moves northeast first, but it does not continue straight. The Arakan Hills force it to deflect. This is sometimes described as the boomerang effect. One arm moves along the Brahmaputra Valley. another flows westward along the Ganga plains. This deflection explains why North India receives substantial rainfall from this branch. Now, rainfall, however, is not uniform. Topography controls intensity. Distance from sea matters. As moist winds move inland, rainfall declines. But topography can override distance. Take Monsoon. The Meghalaya hills, Garo, Khasi, Jaintia, create a funnel effect. Moist winds are channeled and forced sharply upward. The result? Extreme rainfall. This shows a key rule. Relief can amplify or suppress rainfall beyond simple distance logic. Now, even this rainfall is not steady. Monsoon has breaks. The monsoon trough, an elongated low-pressure belt across North India, controls rainfall. When it shifts northward toward the Himalayas, plains experience dry spells. The Himalayas receive intense rain. This explains alternating wet and dry cycles during the season. Understanding this helps explain floods in foothill regions and dry spells in central plains within the same monsoon. Now we introduce a global spoiler, ENSO, El Niño Southern Oscillation. This is a Pacific Ocean atmosphere phenomenon. El Niño weakens the Indian monsoon. La Niña strengthens it. Pressure difference between Tahiti and Darwin acts as an indicator. When pressure patterns resemble El Niño, monsoon circulation weakens. So even though the monsoon is Indian, its stability depends partly on the Pacific. But there is a variation many overlook. El Niño Modoki. Unlike classical El Niño, warming occurs in the central Pacific. This alters the Walker circulation, the east-west atmospheric circulation across the tropics. Different warming location means different rising and sinking zones. That shifts global rainfall impacts. This is why Modoki cannot be treated as identical to standard El Niño. Now let's move to the retreat phase. Monsoon does not withdraw suddenly. Retreat begins in northwest India in September. By mid-October, it withdraws further south. Then comes October heat. Clear skies, moist soil, high temperature. Humidity rises sharply, producing uncomfortable conditions. This is a transitional phase between wet and dry seasons. But one region benefits from this retreat. Tamil Nadu. Why is Tamil Nadu dry in summer? It lies in the rain shadow of the Western Ghats for the Arabian Sea branch, and the Bay branch often runs parallel to its coast. But during retreat, winds reverse. Northeast monsoon winds pick up moisture from the Bay of Bengal and bring rainfall to Tamil Nadu. So Tamil Nadu's main rainy season is winter, not summer. This reversal is one of the most common conceptual traps. Now finally, impact. The Indian monsoon is an economic gamble. Nearly 64% of agriculture remains dependent on it. Rainfall ranges from less than 12 centimeters in the Thar Desert to more than 250 centimeters in the Western Ghats. Uneven distribution creates uneven development pressures. When you think of the monsoon, don't think only of clouds. Think in sequence. Pressure difference, ITCZ shift, Mascarene high, Arabian and Bay branches, topography, breaks, ENSO influence, retreat, economic impact. When that entire chain sits clearly in your mind, from mechanism to consequence, the monsoon stops being a chapter. It becomes a system you can explain. And when you can explain it end to end without hesitation, you will be exam ready.